If there are no questions on any of the previous assignments, what we're looking at today is synthetic division. Synthetic division is another way to divide polynomial functions. And for the most part, there's been maybe a handful of students that I've had in the last 7 years that have liked long division better than synthetic division. When we divide polynomials using synthetic division, the first thing we need to do is we need to get our quotient, the variable m, by itself, or the term with the biggest power by itself. So here we have n minus 3 is equal to, and we'll set it equal to 0. So to get m by itself, we'd add 3 to both sides, which would tell us that m is equal to 3. Okay. Any questions on this so far? All right, now to set up the synthetic division, the first thing we're going to put is a cubbyhole and a line. Now the number that goes in the cubbyhole is going to be the 3 that we solved for. Now the next thing we're going to write in is going to be next to the cubbyhole, and it's going to be all of the coefficients, the numbers in front of our variables. And if we're missing a variable, we're going to plug in 0 for each of the variables that is missing. Now here, the first variable that we have is m cubed, and the number in front of m cubed is 1. The next number is negative 13, 24, and 18. Now for this problem here, we don't have any variables that are missing because we do have m cubed, we have the m squared, we have m, and our constant term. Any questions on this so far? Now after we get it set up, our first main step is going to be to drop the 1 down. We bring the 1 down. And our next step is we're going to multiply. We're going to do 3 times 1. I'm going to erase this here. Got a little more room. So 3 times 1 is, and we put that number under the negative 13. Any questions so far? We add straight down. Negative 13 plus 3 is, okay. We multiply again. We do 3 times negative 10 is negative 30. And we put it underneath the 24. And then we would add straight down. 24 plus negative 30 is, and what would we do next? 3 and our negative 6, we'd multiply those together, so 3 times negative 18. And we would, 18 plus negative 18 is 0. I always box the last number. The last number is the remainder. The last number is going to be our remainder. The number after it is the constant term. The one after it is going to be x, and the one after that is x squared, because we fill the variables back in. So this one here divided evenly, and our actual answer is x squared minus 10x minus. That's it. questions on this here? Let's look at another one. To see how this works. So the first thing we're going to do is, here we're solving for v. Now, I'm going to pause right here. I'm going to tell you this right now. If you flip the variables and don't put the correct variable down, I'm not going to count off. Because what did we say our answer was? X squared minus 10x minus 6. What was our variable? M. I'm not going to count off for that. Okay? They all pretty much are the same thing. The only place that we would run into issues is if we have more than one variable being used at the same time. Then we need to keep them straight. Here, it's not that big a deal. Okay. Let's get back to this here. So we have v plus 4 is equal to 0. So v is equal to negative 4. When we really have these binomials, we're just really switching the sign in front of 4. Now we can set up the problem. Cubby hole and the line.
What's your little line?
It's for using the synthetic division. Is what we get below the line will be a part of our answer. Now you're good. Now the numbers that go across the top here are going to be from our polynomial here. And we need all of our terms. So the first one would be 8, 32, and then 20. Yes.
Yeah.
So our first term is 8v to the 5th, yes? And then the next term is 4, 3, 2, 1. So v to the first. And really we do have v to the 0, but anything to the 0 power is 1, so it's our constant term. So we need every single term. Our next step is to bring down the 8. And then we will multiply. So we'll do negative 4 times 8. We'll put the negative 32 under 32, and 132 plus negative 32 is 0. I'm not going to write these next few multiplications out because I think we're good. 4 times 0 is? Okay, I'll put that there. 0 plus 0. Negative 4 times 0. 0 plus 0 is? Negative 4 times 0 is? 5 plus 0 is? Okay, now we're going to do?
Wait, why did you do 0?
So negative, or 32 plus negative 32 is? So we multiply with each number. So negative 4 times 0.
So you stay at the same one?
Yeah, so we're going to be multiplying each one of these by the number in the cubby hole. Now we have to do negative 4 times 5, which is and 20 plus negative 20 is, and again we box the last number because it is our remainder. And I find that a good way for me to remind myself that that is the remainder. The number that's after the remainder is our constant term. Then we'll have, I'll use v to the first, v squared, v cubed, and v to the fourth. So our final answer really is 8 fourth plus 5. But since all the rest of them were 0, we don't have to include them in the answer. And that's it. Questions on this here? Do we like this better than long division? Any questions on any of this so far? Now there is a trick with synthetic division. Or not trick, but there is a piece that does make it a little more challenging. And it's when the number in front of x in our binomial that we're dividing as our divisor has a number in front of x. Since this has a 3, we're going to have to divide everything by 3 now or later. Might as well do it now, because we're going to have to divide both of these by 3. We're actually going to have to divide everything by that number. So if we divide everything by 3, we get x cubed minus, not 4, 4/3 x squared minus 17/3 x plus 2. Now, because the 4/3 won't reduce, it doesn't divide evenly, and 17/3 won't simplify evenly, we'll leave them as this here. What number is going to go in the cubby hole? Not negative 1/3. It's going to be 1/3. Because from our divisor, we can set it equal to 0 to get x by itself. We would add 1/3, so x is equal to 1/3. So in almost all of these here, we're really just flipping the sign and moving it over. Now the numbers that go across the top would be 1, negative 4/3, negative 17/3, and 2. And we'll bring down the first term. I'm going to erase this here, so if I need to, we can write out our multiplication or addition, subtraction. So our first multiplication is going to be 1/3 times 1, which is and then we would need to add straight down. So we have to take negative 4/3 plus 1/3. It would be negative 3/3, which is negative 1. That's kind of nice, isn't it? 1/3 times negative 1 is negative 1/3. Well, this here, because the bases are the same, so we can add the numerators. So negative 17 plus negative 1 is, well, negative 18/3. 18 divided by 3 is 6, so this is. And lastly, we're going to do 1/3 times negative 6. And negative 2 plus 2 is. So this one actually worked out nicely that we actually got whole numbers and not fractions. And now we just need to plug the variables back in. This would be our remainder. Negative 6 would be the constant term. Then we would have x and x squared. So our answer here would be x squared minus x minus. That's it. Questions on this here? We good with this here? Now, it won't always work out this nicely that the fraction will simplify completely. We can have some where we get some very ugly fractions the further along it goes. depending on how the problem is set up. Any questions on any of this here? Is there another one of these synthetic division that y'all want to look at? You want to look at the rest of them and see if there's one of those in particular you want to look at before we move on to evaluating. Next one. This one. What makes this one different? So we have a quadratic instead of a linear equation. We have a trinomial because we have 3 terms here, yes? And all the others we have 2. Now I include this one in here so that y'all can see it and see that this does work. That synthetic division, I don't know why I lost the term for a second, works for any type of divisor. We can have quadratics, we could have cubics, we can have quartics, we can have any of these here, but the way we do it changes just a little bit. For starters, when we start off with synthetic division on the last ones, we solve for x. We got x by itself. Here, we're getting x squared by itself. So we want to get all the other terms besides x squared onto the other side. So we can do that by first adding 4 to both sides, which will tell us x squared minus x is equal to 4. And then we can add x to both sides, which will really tell us that x squared is equal to x plus 4. So with it being a quadratic as the divisor, we don't get x by itself, we get x squared. We get the biggest term by itself. Nope, we just need the x squared term by itself. Because it's giving us the numbers that go in the cubbyhole. So what is the number in front of x? And then our other number is 4. So both of those numbers will go in the cubbyhole. Now when we had 2 terms, we did have 1 line, yes? Yeah. Now, because the ones we did before, we had the cubbyhole and had a line, because we had 1 number in the cubbyhole, yes? There's going to be 2 lines this time. Because now we have 2.
One question.
Yes. If you take college algebra. Now this one here, I'm really just wanting to show y'all that this does work and how this works with this. But we could use this with long division and get to the same answer just fine. Now the last thing we do need to do is write our coefficients, the numbers in front of the variables up here at the top. Any questions on how we got this set up so far? Now, just like with the ones we did before, we're going to have to drop the first number, and it's going to go all the way down. So the first number is going to go all the way down. So it's going to go down below the second one. Any questions on how we set this up so far? ready for the next step.
I think we need to send it to Brad.
Now, we're going to multiply both of these numbers with the bottom number, so 2. So we're going to do 1 times 2, which is 2, and we put it here. So that 1, the number that was associated with x, whenever we do the multiplication, it's always going to be above that second line. The 4 is going to be multiplied with the 2. 4 times 2 is 8. And its numbers are going to be all on the top line. Add straight down. 1 plus 2 is? Negative 15 plus 8 is?
So we're pretty much going to have 2 answers. That's 1 answer.
So it's this down here is going to be the final answer.
Oh, really?
So it's at the bottom line. When we get all done, will be the final answer. Now we'll do it again. We'll do 1 times 3 this time, which is 3. Now we're going to do 4 times 3, which is 12. And then we can add. So negative 7 plus 3 is? Negative 2 plus 12 is? Now we do it again. We do 1 times negative 4, which is negative 4. And then we'll do 4 times negative 4, which is negative. And then again, we're going to add straight down. 10 plus negative 4 is 6. 10 plus negative 16 is negative 6. We're going to do it one more time. 1 times 6 is 6. And negative 4 times 6 is? We're going to add again. Negative 6 plus 6 is? Negative 24 plus 24 is 0. So we've run out of numbers to use. So we will bring the 0 down. And these last 2 are the remainder. Because how many terms did we divide by or with? 3, because we had a quadratic, we had 3 terms. So the remainder is going to be 2, because we'll have our constant term and our term with x with the remainder, because the remainder can have an x term. But both of these here are part of the remainder. Now 6 is our constant term. Negative 4 is our term with x. 3 is our term with, and 2 is the term with x. So the actual final answer is 2x cubed plus 3x squared minus 4x plus 6. Now this one here, you could have done it with long division instead and got to the same answer. And we could do this with cubics, essentially having a 4 term that we're dividing by, but instead of having 2 lines, we're going to have 3. Because for each term that we add to the divisor, each term that we add to this here is going to add another line to it. Because we're dealing with, instead of 3 terms, we're dealing with 4. And we would get the cubic by itself and follow the same steps. Now, one thing that's interesting is, what is the degree of the polynomial that we started out with? 5, and we're dividing by a degree of 2, yes? What was the degree of our solution? So dividing by a degree 2 took it from a degree 5 down to a degree 3, yes? Well, here we're dividing a degree 3 by degree 1, yes? Our solution was so each time we divide, we're decreasing the degree by 1 or however much the degree of the bottom is. And that's helpful. The degree of the new one. Yeah. There are some things I can hear quite well, others I can't hear much. I haven't had it. It ain't good.
More guys are colorblind than girls.
Yeah. All right, guys, one last thing we're going to look at, and that is evaluating a polynomial using synthetic division. This is the last thing we're going to look at today. So when we talked about evaluating a polynomial, guys, let's focus back in. What we would do is we would plug it in. Because we evaluated polynomials earlier this week. And to evaluate it, we replaced x with whatever that number was. So here we're going to replace every x with -4. And at this point earlier, we would plug the entire thing into the calculator and let the calculator evaluate it for us. What did you get, Bruni? I would agree. So if we plug -4 in for x and had the calculator simplify it, we would get -359. Now, let's use synthetic division. Now, the number that we plug into the cubbyhole is going to be -4, guys. Now, we're going to use -4 because x minus 4 has already gotten the x by itself. Because when we did that in the first step where we were given the term like x plus 4, we got x by itself by subtracting 4. And that's what we would have here. Now, the numbers that go across for this here would be 5, -1, 13, and 29. We don't have to put any zeros in because all of our variables are there. So our next step would be to bring down the 5. So we would do -4 times 5, which is negative. Add straight down. Guys, -1 plus -20 is -21. Then we would multiply it with -4. Well, the negative, Caleb, the negative would make a positive. And 21 times 4 would be 84. Well, almost 97. Because then we would add straight down. 13 and 84 would give us 97. And lastly, we're going to take -4 times 97, which will give us bless you, 8 carry the 2, 388. And if we add straight down 29 plus -388, we get what? And -359 would be the remainder, yes? Is there anything interesting about that number? So whatever the remainder is will be the same as if we plug that number into the equation. Well, that's also telling us something interesting. Because if the remainder is 0, that means we can divide it evenly, yes? If, because when we talked about quadratics, whenever we plugged a number into the function and it became 0, it told us it was a solution. When we divide, if we get 0, it divides evenly. It means it's going to be a solution. But it's also doing what else? It's taking the degree of the polynomial. Here, it would take it from 3 to 2, yes? So by dividing, we can decrease the overall degree of the polynomial. Now, tomorrow, we're actually going to be, we'll look at one more of these here. But tomorrow, we're going to start our chapter on solving. And actually solving these higher degree polynomial functions. Have we actually covered a single way to solve a cubic or a quartic or any of these higher degrees? Well, no. Do we know how to solve quadratics? Well, yeah, last chapter, well, the chapter before, we had multiple ways to solve a quadratic equation. So, if I can find some of the solutions, I can use division to bring it from a degree 3 down to a degree 2, and we can solve. Because if I can bring these higher degree polynomials back down to a quadratic, a degree 2, then we can use those formulas to solve. And that's the big thing with division, is bringing down the degree back to something we can use or solve. Any questions on this here? No? Yes. Let's do one last one here.
Or chair. Or, you know, we could be a trio. I'll do them, y'all make them. Okay? Y'all can split half of the halves, and I'll take the other. Half of the half. Yeah, it is. Quarter. Doesn't it make sense?
Half of the half.
See, I get a half. Y'all get like half of the half. The other half. Okay. I get 50, y'all get 25. Yeah, that's what I said.
So 5 times 4 is? And negative 10 plus 20 is? And 10 times 5 is? 50. Mm-hmm. So the answer for this here would be 29. Any questions on any of this here? And that's it. The homework.
Me and my mom did before school. You said it would be 3 to 4 nights a week. So let's go tomorrow.